Go.
Welcome to Calc2.
Hello and welcome back to Calculus 2, section 7.3 on trigonometric integrals. The entire section just trig, and you know what that means. You need to know the identities, otherwise you are doomed. So, we are going to use trigonometric identities and U sub in this section. Now, this section is set up for the next section, 7.4, which is trigonometric substitution, where we take the regular expressions with x's and so on, and change those into trig to make it integrable. So we'll get there. So this is, in some sense, a preliminary section to learn some tricks of the trade. So where do we begin? We begin with first reviewing those few identities that you must know, otherwise you're done. The first one is obviously Pythagorean. Well, let's go with the tangent x is equal to sine x over cosine x, and cotangent x is equal to cosine x over sine x. So these are the first two identities we talk about. Then we have also that the secant x is 1 over cosine x, and the cosecant x is 1 over sine x. So these are all basics. Next part is to talk about the Pythagorean identity formulas. So we have that sine squared x plus cosine squared x is equal to 1. Now, this you can rearrange, right? You can get sine squared x as 1 minus cosine squared x, and you can get cosine squared x as 1 minus sine squared x. So these are important because you will use them in all possible ways. So it's one formula, but it has three forms. One is solved for 1, one is solved for sine squared, and one is solved for cosine squared. Now going back to the original formula, if you divide everywhere by cosine x, you will get that the tangent squared x plus 1 is equal to secant squared x, which also has another two forms. So you can solve for tangent x, so tangent squared x is equal to secant squared x minus 1, or you can solve for 1, which is secant squared x minus tangent squared x. So as I said, all of these guys will be handy eventually. And then we have the cotangent squared x, if you go back to original formula and you divide everywhere by sine squared, you get 1 plus cotangent squared x is equal to cosecant squared x, which also has two forms. One when you solve for secant, for cotangent, and one when you solve for 1. So 1 is equal to cosecant squared x minus cotangent squared x, and finally cotangent squared x is equal to cosecant squared x minus 1. Everything that you see currently on the page is derived from the first equation here. All of the other formulas. So you actually have 9 formulas there, where it's sufficient to actually remember one only. And if you divide that one either with sine squared or cosine squared, you will get into the other formulas below. The formulas on the right hand side are simply rearranging terms from what you have on the left. Right? So you can solve this for sine. That means move the cosine to the other side. And that's this equation. That's exactly what happened. We just took the cosine out and put it on the other side, so you get the first equation like that. So we can rearrange any of these that we want. And then we have our power-reducing formulas. Yeah, it's done. If you don't know these formulas, you are doomed. So cosine squared x is equal to 1 plus cosine 2x over 2. And sine squared x is 1 minus cosine 2x over 2. Out of everything, these formulas are the most important. Well, Pythagorean identity as well. But what do we need this for? The only way to integrate cosine squared x dx is to integrate 1 plus cosine 2x over 2 dx. I know we did this earlier in a class at some point, but let's write it one more time. So I can kick 1/2 outside. When I integrate 1, I get x. And when I integrate cosine, integral of cosine is positive sine. So I have plus 1/2 sine 2x. And we have plus c. Observe that when you see the problem in its original state, there is nothing you can do other than the formula. Everything else is going to fail, no matter what you see, because you don't have enough building materials for u sub, and it's not integration by parts, so there you go. The next very important thing is to remember trig pairs. So throughout the entire thing, whether you're taking derivatives or integrals, you will always end up in the same pair. So we have sine paired with cosine. We have tangent paired with secant, and we have cotangent paired with cosecant. So these are the trig pairs, and believe it or not, a lot of your problems in 7.3 will depend on your ability to actually, work through this and make sure you're using right identities so you can put the integral in the form that you need to do the u sub at the end. Now it's time to start with basic integration problems. So we are done with identities. Identities, as I said, the basic definition for tangent and cosecant and so on. Then we have our formulas for Pythagorean theorem, and then we have the power reducing. Yeah, the double angle and all the other ones, sure, but what I have there is a bare minimum for you to survive Calc2 and later differential equations. The first problem of the section is going to be the one that we did already, I believe, twice. We're going to go with the sine to the 6x and then cosine x dx. So what should I do here? Or maybe I could start with, what is the most noticeable thing in this problem? The pair. The pair between sine and the cosine. As soon as you have pair, that screams what? U sub. Because the derivative of cosine is sine, and the derivative of sine is cosine. Yeah, there's a minus sign floating around, but we don't care. So this is clearly u sub. It's u sub because function and its derivative are present. So u equals sine x du equals cosine x dx. If you already started your lab, you've seen what happens when you make wrong choices. I don't mean wrong choices of starting the lab. I mean the wrong choices from the problems that are presented on the lab, and some of those problems, right, are asking you to make a wrong choice so you can learn from it. Then you have to write paragraphs. I know, it's like English paper. To explain why the choice was wrong. How did it go wrong, and all of these kind of things. I really hope you didn't waste the weekend. You actually did a lot of lab too, because as I said, it's 5,000 pages when you hand in. It's like the booklet. Yeah, don't see, I don't think anyone actually opened that lab because you are still really relaxed. Because you don't believe me.
Well, when's the second test?
You will tell me that. But see, the labs 2 and 3 are for the next test, which is, you might be next week.
The next 2 chapters, I mean?
No, labs 2 and 3, if you paid attention, I said that in class, the labs 2 and 3 cover chapter 7.
I know, I have it all written down at the end. Allegedly.
Allegedly.
It's like,
All right.
8,000 chapters.
So I hope you all have the same answer for this vanilla warm-up problem, right? All right, let's open the gates of hell, see what's in. How about sine cube x cosine square x dx? You see? This is not a problem. This is a problem because both trig functions have exponents. We know their inverses of their pairing, right? Because sine and cosine, and either one of these could be function and the other one left with du. To use u sub, u sub from Calc 1. But when you look at this problem, what should I do? Power reducing formula definitely should not be used because power reducing formula is going to create double angle on one. You will have single angle on the other. They will not be compatible. So power reducing formula doesn't work in this particular case. So what should I do?
Give up.
Yes.
You can turn sine cube into sine of x times sine cube times square of x.
Nice. You peel off. If you have odd, guys, this is a rule. I'm hoping you are remembering it or writing it down. If you have one of the exponents to be odd, that's what you peel off sine or cosine, whatever is underneath. So when you have exponents on everything, you will, if one of the exponents is odd, you are going to peel off one of those trig functions from there and save it for du. So we are going to start by peeling off a sine x, and then we are going to move that sine x at the end. If they both have odd exponent, pick one. So we do this and we peel off. Great. What is the sine derivative of? Of cosine. So we have to have cosine for u. If cosine is equal to u, then du is sine, and we're good to go. The issue is, what am I going to do with the sine square in front? I can get this into u squared. I know this is du. What I'm going to do here? Again, do not mention power reducing in this case because that will create double argument. Yes? Beautiful. Use the Pythagorean theorem to switch that into cosines. Combine them with these cosines. You have all cosines over there, and then here's your u sub, and you do it. Very good. So, to deal with this, we are going to use the fact that sine squared x is 1 minus cosine squared x, and that is on the list of things that I told you that we are going to use, right? It's right there. So our integral now becomes 1 minus cosine squared x times cosine squared x times sine x dx. When I distribute, I get cosine squared x minus cosine to the 4th x sine x dx. And then some people find it easier if they split into two integrals, right? And then you integrate each one separately. So the first integral on the left is going to be cosine squared x sine x dx, minus the other integral is cosine to the 4th x sine x dx. This distributes for every function inside, so it distributes both ways right there. Now we integrate this. U is equal to cosine x du is equal to negative sine x dx, and we use this substitution. We use this substitution to go and transform this into, the first integral is negative, so negative u squared du, and then plus over here because minus from here and minus from there, it's a plus. So plus, and you have wait, what do you have then? Oh, u to the 4th du. That's from the second integral, so that's that. And now we integrate this, so we have 1/3 u cubed plus 1/5 u to the 5 plus c, which will give us the cosine, so that's 1/3 cosine cubed x plus 1/5 cosine to the 5th x plus c. And that will be the answer. Yeah, I know it's not pretty, but it is what it is. Going back to the original idea over here, put this into a peanut, and you look at this and you say, all right, this is where you break it into sine squared and basic sine, and then move everything else to the opposite trig function, so that you can do, I mean, not opposite trig function, into the function that you need to, so you can solve the problem. There are no opposite functions. Let's take a look at some textbook examples. Let's see what they have. They have something cool. Yes, they do. It's really cool. Problem number 19. Could have saved it for the exam, but I haven't. I have to think of something else now. Integral of cosine cubed x square root of sine x dx. Do you see that this is the same as the previous problem? You have an odd exponent. You peel off the cosine, and then you go from there.
I found the ride. I don't care about Robin. I found the ride, but people gotta get home. I can text Robbie. Robbie's going like I said sure. Okay. I mean yeah. Okay. I said I found the ride. Oh. You see the frowning face. Oh, before that. I said the frowning face.
I was distracting him.
Never sending me. Because you're never disappointed. Yeah, exactly. Why would I disappoint you? No, we're talking about, I don't know, I can't have a full conversation though. We're talking to Alex. Alex is like, you never sent me your pathing, so you need a ride. I was like, alright.
Alright, so this problem is, I see you guys are done. This problem is exactly the same as the previous one. I'm just going to outline. So this will be cosine x times cosine squared x. So that's what we break it with. So integral 1 minus sine squared x, that's the cosine part, times the square root of sine x, and then we have the cosine x dx. So now integral, you have the square root is 1/2 exponent, so this is sine to 1/2 x minus sine to 5/2 x, because when you have sine squared, that's 4/2 plus 1 is 5/2. And then you have your cosine x and then dx. So again, u equal sine x, du equals cosine x dx, and you plug in everything. So this becomes u to the 1/2 minus u to the 7/2. Now we need to divide by 7/2 over here, and we need to divide by 1/2, which is times 2. Good. Plus c. Oh, I integrated already. I'm not sure why I'm putting that in. Okay, plus c. There we go. So this is 2 times sine square root of sine x minus 2 over 7 sine x raised to the power of 5/2.
What did the 2 times u to the 3/2 for 3?
Where?
The interval of u to the 1/2.
Okay. Oh, yes.
Something you integrated it.
It's 3/2.
Over 3.
So over 3.
Yeah. Okay.
So this is over 3. Okay. We're good, right? Now, The next, yes.
Why did you drop the other powers? On the side of it and put it back in?
This is 3/2, right?
Oh.
And then plus c. Oops. So here's the next challenge. You do not have odd exponent anymore to peel off one of the trig and convert the rest. Both of these powers are even. I mean, you can go with a 4 and a 2, it's okay. You definitely don't want sine to the 10 times cosine to the 10. That will take a few hours. But this one is okay. What do you think you should do to integrate this? Yes?
Change sine squared of x into 1 minus cosine squared of x.
Will it achieve anything?
Well, not yet.
Okay.
And then you can multiply the cosine squared of x in.
Okay.
You can use the half angle formula and continuously break it down. And then you
Can we just use, power?
Not called half angle formula? No.
Yeah, well, actually, well, if you put it around, yes, it is. You can use that one too.
Oh.
So use power reducing formula twice, guys. Go. Shuffle through this algebra. Let's see what you get.
No, you can put the cosine.
You have power reducing for both of them, right?
Yeah.
And they will both come out to be equal to cosine. Because, right? Both of them have cosine 2x.
Come on.
Alright, let's see.
No? You don't say that about me ever. You're like, yeah, this one falls behind all the time.
This problem was like 5 problems ago.
You remember that? I'm trying to find the rod. I'm serious. Look on my phone, it's like, can you do me a favor? No response. Can you do me? They all know what I'm asking for. Well, we can do it.
Yeah, we're not getting the true stuff to work. This problem, and then we have to
Playing these on the screen. I'm lost. That's just across the wall. Yeah. That's just across the wall.
Yeah.
Not teach the class. Well, what's today then?
You have done class, but you know.
Huh?
You have done class, but you know.
I did.
How do you know that?
So I was doing the old class prep. I was like, I do class prep.
You think I want to quote it or want to quote anyone in the class?
Put me up. So confused. Supposed to be using these, right? No? There's no reason? My class prep was a waste of time.
All right, so as we said, this problem doesn't have any odd exponents. If you don't have any odd, right, everything is even, then we have to go and use the power reducing formulas. Some of you call them half angle, whatever. So now we have integral. The first one is 1 minus cosine 2x over 2, and the second one is 1 plus cosine 2x over 2 dx. we kick 1/4 outside, and we FOIL what's left. Now what's left is 1 times 1 is 1, and then minus and plus, so that's gone, and then we have minus cosine squared 2x dx. So half times half gives us 1/4 outside, and then it's a difference of squares, right, backwards. So you just put 1 and then minus cosine squared. Here's another cosine squared. Power reducing again. So 1/4 integral of 1 minus, and now we have 1/2 in parentheses 1 plus. Well, I'll put it the form you're used to it. So it's 1 plus cosine 2x over 2 dx. So now I have a half and a 1 that can combine.
The fact that it's squares.
Oh, that's a 4x over here.
Yeah.
It's a 4x over there because it doubles the angle every time.
Is it 2 plus and plus?
Yeah. Isn't the 4 on the bottom too?
No.
I think it's the form. I think it's 2 plus and 4x.
This is a 2 for now. So I have 1 minus a half is a half. Minus 1/2 cosine 4x, and finally I can integrate because I don't have any more exponents on trig, and I have a single trig in each of the each of the terms. So now when I can factor out 1/2, so that's 1 over 8, and I have integral of 1 minus cosine to the 4x dx. So what do I do? 1 over 8, the integral of 1 is x, minus the integral of cosine is positive sine, so sine 4x over 4, and then we have plus c. That's it. What, disappointed?
Here, scroll up a little bit. Of the step where you made it to 1/2 minus 1/2 cosine 4x. How did that get to half minus 1/2? How did you go from the one above that to that? Yeah. No, the one above the 1/2 minus 1/2.
Oh, from here?
The 1/2. Yeah. How did you go from?
Ah, I went like this. You see a 1/2 over here? So 1 minus a half is a half. But this half over here belongs to both this part and this part.
Yeah.
So there you go.
You split it, and it was 1 minus 1 over 2 plus cosine 4x.
When I split the fraction, it becomes 1 over 2 plus cosine 4x over 2. And then there is 1 minus in front.
Oh, then you should, and then that.
Oh, and this is also minus because of the... Okay. Make sense?
Yeah.
Good. Magic. All right, so rules for sines and cosines. Number 1, if one has an odd power, peel it off, and maybe I should say peel it off. No, it's good. Peel it off and transform the rest. Number 2, if all exponents are odd, no, all exponents are even, then use power reducing. So that's what I have. If you have at least one or both exponents to be odd, you peel off a value and you transform the rest. Because when you peel one off of the odd number, right, you get even number. An even number can always be dealt with the power reducing. If both exponents of sine and cosine are even, then you get to use the power reducing right away. So that's the first part of the lecture. That is only sines and cosines. The next trig pairing is secant tangent. Okay. This is trickier, much trickier. You know that the sine and cosine, they go very easy with the derivative, and right? When you think about inverse, when you think about sine, the secant tangent pair, we don't deal with the integral of secant. We don't deal with the integral of tangent. They're not basic integrals. So what are the basic integrals that we need to survive this? No coughing. We start by writing that the derivative of tangent x is secant squared x. And also that the derivative of secant x is secant x tangent x. These are your Calculus 1 formulas for the derivative of secant and the derivative of tangent. Now this means that the integral of secant squared x dx is equal to tangent x plus c, and the integral of secant x tangent x dx is equal to secant x plus c. It is very important to know these, otherwise you won't be able to do any of the problems. Please observe the strings. Over here we have secant squared, and over here we have secant tangent. So these are the ones that you somehow have to leave behind to get your substitution. So let's see. Let's see some of the problems. Oh, it keeps lagging me out. So let's go with the vanilla example. 31. Integral of 10 tangent to the 9 x secant squared x dx. This is a one-liner problem. It looks terrible, right? You also see the secant squared. You might start freaking out. Don't, because the derivative of tangent is secant squared. When you see secant squared, you won, because the problem is the basic u sub. You know that the derivative of tangent is secant squared, What's your function derivative pair? Tangent secant squared. I have tangent, I have 9 of them, but who cares? It's just going to be u to the 9th. And here's your du entire. So when you see secant squared floating around and a whole bunch of tangents, you're happy. You should be happy. It's a basic u sub because of the first line in green, which says that your function is tangent, and then for du, you have secant squared. So now I can immediately set up this u sub and be done. As I said, it's one-liner, one-line problem. U equals tangent x, du equals secant squared x dx. You do have secant squared x dx. Perfect. So we kick 10 outside. We have integral of u to the 9 du. That's it. The whole thing collapsed into u to the 9 only. Again, your function is tangent, so tangent to the 9 is u to the 9. And then the derivative of tangent is secant squared. You do have secant squared, and you just replace it now. So now this is going to be u to the 10 over 10, and 10 and 10 will cancel, so it's just u to the 10 plus c, which is tangent to the 10x plus c. And that will be the answer. Now let's say you care. What would you do? You would check it, right? If you care, you would check it. So when you take the derivative of tangent to the 10, you get 10 tangent to the 9 times the derivative of the inside, and the derivative of the inside is secant squared. It gets to be exactly the problem we had over here. So every time you're done with integration in chapter 7, that goes for entire chapter 7. Guys, you're integrating in every single section throughout 7-9. The coolest thing about integrals is that they can be checked using derivatives. When you take the derivative, you just hope it's right. Yay, right? Experience and hard work kick in. But for integration, well, if you're good with your derivatives, you should be able to take a quick derivative using chain rule or whatever to come up with whether the problem is right or wrong. Let's see some more diabolical setting. Oh, when as we are talking about problem 31, toss in the problem 36 in the same light, except they tell you it's a secant squared divided by tangent to the 5th. Secant squared x divided by tangent to the 5th x. Again, you have the secant squared in the numerator. If the secant squared is in the numerator, that means it came from the tangent u sub, right? So what are you subbing on the bottom? It's just going to be du over u to the 5. And then you use integration to integrate u to the 1 over u to the 5. And then you get negative 4, right? As the exponent. Well, let's see a different type of a problem. So we had secant squared given to us. What do you do when secant squared is secant to the 4th, or secant to the 6th, or secant to the 8th, right? What do you do with those? So now the next question is, and I'm going to recycle the previous one, so I'm maybe, there's the yellow over here. I'm going to say integral of 10, well, I need 10, just tangent to the 9x secant to the 4th x dx. So you do not have secant squared anymore. Now it's secant to the 4th. What now? What do you think? Split secant into 2, secant squared times secant squared. Great. So we're going to save one secant squared for du. What am I going to do with the other secant squared?
squared x.
What?
9.
Turn into
1 over cosine squared.
You have to keep the pairing. The pairing is secant tangent. You are not allowed to break the pairing.
This is amazing.
What?
Tangent squared x plus 1.
Yes, Pythagorean identity.
You're just looking up.
You have to know those Pythagorean identities have to be your go-to place. It's Pythagorean identity. It is splitting these guys. It is also the, but it's Pythagorean identity. Going back all the way to the top to remind you that the unwanted secant, right? One you keep. You have to keep one. The other unwanted secant square is going to be turned into tangent, and all of that is going to go onto a pile, and we'll do more work on that. So now, break the secant into secant squared x, secant squared x. When you break those, so now it's integral tangent to the 9x times 1 plus tangent squared x secant squared x dx. So one secant was broken, the other one was kept for our du part, for u sub. It takes time to get used to this, guys. There's going to be a lot of homework. And tomorrow's lecture depends heavily on your ability to do these. So if you are not learning this for tomorrow to be comfortable, at least as much as you can be, trigonometric substitution is not going to be too hard, because in that lecture, this is assumed. This is something that you just do quick, right? Like you were doing u sub, now quick. So the next lecture is going to be all about setting up trigonometric functions and dealing with things, right? And then you end up with a trig integral that needs to be solved. What if the trig integral you got is this? You need to know how to do it. And that's 7.3. So we are starting with a secant to the fourth. Secant to the fourth is an evil thing, because you can't do anything with it unless you split it, and then one secant squared is transformed into tangents, so you can do the u sub, and the other secant squared is kept for the u sub, for the du part. So now I have integral of tangent to the 9x plus tangent to the 11x times secant squared x times dx. And then we unleash the u sub. U is tangent x du is secant squared x dx. And when you plug all of that stuff in, you get integral of u to the 9 plus u to 11 du. That's u to the 10 over 10 plus u to the 12 over 12 plus c. It's 1 over 10 tangent to the 10x plus 1 over 12 tangent to the 12x plus c. As you can see, these answers are getting longer, right? That was the problem for even secants. What happens if the secants are odd? Right? If secants are odd, then you better have another tangent floating about. So when you break off that one secant, let's say you have secant to the 3, right? Well, secant to the 3 can be broken into secant squared times a single secant, and if there is a single tangent, secant tangent dx, I can do u sub, right? Now, the nastiest problems, right, in the whole section are with odd exponents of secant. Especially beautiful problem for those of you that want to explore just the basic secant cube dx. What's the integral of secant cube dx? You know, try that one. Not gonna be easy, not gonna be fun for some time till you figure out what the step actually is. You can try converting and doing all kinds of things. Nothing works. It's like one trick that you have to use. Yes. Yes, that one. Integration by parts.
Kind of a weird question, but why is the unit circle that we're taught like not inclusive of like cosine and cosine and all of the
We'll talk later, but no.
Rare sign?
It's the yes. This is a basic $700 course. So you need to be in a $2,000 course.
A rare sign is a sign that appears rarely in the Bible.
I see you taking the more expensive course at one point.
Yeah. I got a refund though. I heard this one's a lot cheaper.
All right, so let's take a look at one of these that have interesting so we have problem 33, integral of tangent x secant cubed x dx. Actually, see what you can do here. Most likely you're going to miss it on the first shot, but that's okay.
Take out minus secant, u equals secant, and then we have u squared, and then u equals 3 plus 3. Plus 3.
Nice.
Right.
Right. Everything you said is correct.
Sick. Lego what? The coffee notes? Yeah. Yeah, I'm confused. He said Lego with all caps. Like, let's go. Is that what you're trying to say?
Wanna go to the movies?
Lego Mike. Pretty good.
I see this problem is really.
I just did.
Yeah, it's Lego my ego.
What?
That's the answer.
Oh, okay.
Of course.
Of course.
You have to add the
That's
Lego
not
just
just
to
like
type
a
the ego.
Didn't I do it right not like 5 seconds ago?
Yep.
You did not just say whatever now.
What's the problem?
Okay, so we break off a secant and we have the integral of tangent x secant squared x secant x dx. So you have secant tangent, right? When you have all of this, so now your u is equal to secant x. Your du is secant x tangent x dx. So the problem becomes u squared du, right? And now we have u cubed over 3 plus c, which is 1/3 secant cubed x plus c, and the problem is solved. Very good.
Pretty good.
Integral secant to the 4th theta d theta from 0 to pi over 4. I know. So this is the last for tonight. I will, before, if I don't get to say this by the end of the class, maybe it should be good to say it now. Your cosecant cotangent pair works the same way, right? Because the formulas are symmetric. They're just negative. So these formulas that you have in green over here, green formulas, let's go. So the formulas that are here in green also work for cotangent cosecant pair, except all of them are negative on the other end. So all of the mathematics and all of the steps from problems that have same exponents and same kind of looking, right, they're all going to be the same, except minus signs will float around differently. So just be careful about that. The rest is actually, as I said, the same. So now, secant to the 4th theta. Well, the only thing that we can do over here is to split it apart, and once we split that apart, we have to deal with it. So what should we do?
Turn to 1 plus tan squared theta.
Okay. Now what does that do?
And then distribute, and then it goes to like secant
That shows
squared
u sub in there
theta
somewhere.
plus tangent squared theta secant squared theta. What?
That shows a u sub in there once we've done that step.
So integral 0 to pi over 4 of secant squared theta times secant squared theta d theta. So what? You transform one or both?
One. Both? One.
Do one first.
No, it's not
No, it's one. You need both.
You need, yeah, you
Because if you
need
convert both, then you have all tangents, and then what are you going to do with that? You're going to go back.
yeah. Do one.
Okay. So if I convert one of them, it will be 1 plus tangent squared theta times secant squared theta d theta. Okay, now what?
Distribute.
So I have integral of secant squared theta plus tangent squared theta secant squared theta d theta. Okay, distributed.
No, you. Alright. So. No, you don't. Wait.
1 over.
No, you don't.
1 over 1 minus.
What? Do you have overload? You are thinking so hard because you want to solve every single one of these problems in your head without writing anything down, and it's just now it started messing because you're mentally tired already. This class is 3 hours is up. That's about the mental capacity of anyone. So. Oh, that's the strategy. Walk in 1.5 hours late, you'll be sharp for the second half of the class. Nice.
The hard part, yeah.
Talk really loud, so
Yeah, so this is done. You just have to do it. So u is equal to tangent x, tangent theta. And then d theta is secant squared theta d theta. Du is, there we go. Now, what is the integral of secant squared? That's just tangent, right? The derivative of tangent is secant squared. The integral of secant squared is tangent. So the first integral is just tangent, theta, plus, and the second one is the integral of, and instead of this one, you have u squared du.
Oh, I didn't even think of this. I was going on.
We'll deal with limits at the end. So plus u, that's a u cubed, so that's 1/3 tangent cubed theta. And here are your limits, 0 to pi over 4. Now tangent of pi over 4 is 1, so I have 1 plus 1/3 minus 0 minus 0, and the answer is 4/3.
Wrong?
Oh, thank you. I know.
No?
So that's that. So we'll do many more of these guys because the next lecture is trigonometric substitution. Trigonometric substitution is going to change your regular looking integrals into trig integrals. So much more of this to come tomorrow.
Yeah. $60. $60 an hour.
60,000 an hour.
60 an hour.
16 an hour?
60,000. 60 an hour. 1,006 hours. Million an hour. Wow, yo, let me cover for one day. One day. Only is a million. Let me just cover for one day.
Your goal is what is this? Oh, that's another question. So you don't even have to come to the next exams. No big deal. And then plus 7 for the next quizzes. So,
no, 28. That's plus 28.
yeah, so see, you don't even have to come.
Just keep going until you get plus 100 one time. Then just don't go.